Welcome back to my channel, and here today we start the elbow complex biomechanics. I know that many of you were eagerly asking for this elbow complex videos to be out, but I don't know why you find elbow complex difficult. But to be frank, I feel that this is one of the simplest complex in human body to study with respect to biomechanics. It's not that difficult, it's not that complicated, and the concept is relatively simple. And if you find it difficult by the end of this session, this series of videos on elbow complex, I'm sure that you will find it much easy. So let us start with elbow complex discussion from today on. Yes, before going in depth into the elbow complex biomechanics, let me ask you, what is the function of elbow complex? What do you think is the function of elbow complex? For example, if you look at my hand, you can see my hand moving always. I'm explaining using my hand. Do you feel I'm using my elbow? Or just think of a scenario where I did not have this elbow complex over here or elbow joint over here. How would I utilize my hand? Can you imagine a situation you are taking a glass of water and you don't have your elbow complex working, or it's fused? You have to pour it inside to the head. How will you do that? It's relatively difficult. For example, you want to comb your hair. How can you do that without the function of elbow complex? So the function of elbow complex is like a elbow complex as a link between arm and forearm. This is the arm, this is the forearm. So it acts as a link between arm and forearm, right? It acts as a link between arm and forearm. It helps in lengthening and shortening of the hand. For example, these movements are always needed. For example, we need to take a pen from here, we need to lengthen it and shorten it and lengthen it. Okay, so lengthening and shortening of the hand is a function of elbow complex, right? Then you know that there are a lot of fine grip activity. For example, when we screw utilizing a screwdriver, or when we use some manual devices, we need these rotatory functions in the hand complex, and that is also a function of elbow complex. That is also a function of elbow complex. So elbow complex literally serves as a linkage between arm and forearm. It helps in lengthening and shortening of the hand. It helps in fine motor activities or manual skilled jobs with the rotatory movement that is possible in the elbow complex. And it increases the efficiency of a hand as a whole, because the hand efficiency is being increased with the simultaneous working of elbow and shoulder complex. If there is a compromise in one of this region, the efficiency of the hand function itself will be deteriorated or decreased. So that's the general introduction in the elbow complex. Let's see what more there is in the elbow. How many joints are there in the elbow complex? The elbow complex is made up of 2 or 3 joints. Any guess? It's made up of 3 joints. This is 3. Yeah, it's made up of 3 joints. One is the elbow joint, which we are commonly referring to as elbow. Okay. The second one are the radio-ulnar joint. There is a superior radio-ulnar joint and there is an inferior radio-ulnar joint, which would be around near to the wrist complex. Okay, so there are a superior radio-ulnar joint, inferior radio-ulnar joint, and there is an elbow joint. So 3 joints makes up this complex known as the elbow complex. If it is asked about the elbow joint, you just have to write about the elbow joint itself. Moving further, we see that in elbow joint, okay, we are taking that complex into simple ones. That is in the elbow joint, which of course we say this joint over here. There is actually the lower end of the humerus articulating with the radius and the ulna. Okay, when it is articulating with the radius, we say it as a humero-radial articulation. And when it is articulating with the ulna, we tell it as humero-ulnar articulations. So there are 2 articulations in the elbow complex, the elbow joint, that is the humero-radial and humero-ulnar articulations. Am I clear? In glenohumeral joint, there is only single articulation between the head of the humerus and the glenoid fossa. But here, there are 2 articulations. One is with the humerus with the radius, another is with the humerus with the ulna. So we call it humero-radial and humero-ulnar. I'll show you the diagram when it will be more easy for you. Now, what type of joint is the elbow joint? Any guess in that? It's a hinge joint. What do you mean by hinge joint? For example, you just go and open your door and close it. That type of action is known as the hinge joint. One directional movement is possible in the hinge joint. But elbow joint is said to be a modified hinge joint or a loose hinge joint. What is that? It's a modified hinge joint or a loose hinge joint. You need to find out the reason for that, right? Why is it a modified hinge joint or a loose joint? That is because if you closely observe my arm function, just look at this region over here. Now when I'm flexing my arm, extending my arm, flexing my arm, extending my arm, if you just place your hand on the ulnar side, you can see that there is a slight axial rotation. You cannot sense it, okay? And slight abduction, adduction movement possible. For example, from this side, when it is going to be in extension, you can see that ulna is slightly pulled into the adduction side, that is medial to the body. When you're extending, you can feel that the ulna is slightly moving away. Only slight movement. You might feel it as the movement of the muscle bulk. So there is a slight amount of such motions of axial rotation as well as abduction, adduction possible in the ulnar side of the forearm when we move for extension to or flexion. So that is why this is known as a modified hinge joint or a loose hinge joint. That is why it is known as a modified hinge joint or a loose hinge joint. Now let me ask you, how many degrees of freedom does the elbow joint has? How many degrees of freedom, any guess? It's not having 2 or 3 degrees. As I told you, it's a hinge joint. Even though it's a modified hinge joint, it has only 1 degree of freedom. Which joint I'm talking about? The elbow joint. That is the flexion extension. That's only 1 degree of freedom. What plane the movement takes place? Any guess in this movement plane? What is this plane? The flexion plane. That is in the sagittal plane and coronal axis. Sagittal plane and coronal axis, the movement takes place. As I told you always, whenever you study a joint, write down a very small heading about the elbow joint. Now write down what type of joint it is, what are the degrees of freedom, which is the plane of articulation, now which are the articular surface. Already we had mentioned the articular surface, humeroradial and humerulnar. What more interesting factors are there in the elbow complex? You can see that there are 2 ligaments associated with the elbow complex. Then there are 5 muscles, which are 3 flexors and 2 extensors, which we'll discuss later. No need to worry about that. If you look at this slide over here, you can see the radio-ulnar joint, and the radio-ulnar joint functions as a single joint. Even though I told you there is 2 radio-ulnar joint, one is the superior radio-ulnar joint and another is an inferior radio-ulnar joint. Both these joints works together to produce the rotatory motion, pronation and supination movement. Okay, pronation and supination movement. What type of joint is the radio-ulnar joint? Again, the same hierarchical order of discussion. The type of the joint, it is a pivot joint. It's a pivot joint. How many degrees of freedom it has? Only 1 degree of freedom. Which is that degree of freedom? That is the pronation and supination. Which is that movement possible? That is a pronation and supination. So the radio-ulnar joints function as a single joint. The superior or the inferior radio-ulnar joint, they function as a single joint. They are pivot type of joints. They have a single degree of movement, that is a pronation and supination. And which plane or axis this movement takes place? Can you just look at this rotatory movement which is taking place? Which plane of axis would that take place? In the plane or axis where medial rotation and lateral rotation takes place, that is in the transverse plane and vertical axis. Transverse plane and vertical axis. I hope that's clear. If you had listened to our video, watched our video on planes and angles, I'm sure that you will be able to distinguish between and identify yourself planes and angles, right? Then other factors, like there are 6 ligaments, oh my god, 6 ligaments. Then there are 4 muscles, 2 are pronators, 2 are supinators. One more interesting factor is there, that is the elbow joint and the proximal radio-ulnar joint is enclosed in a single joint capsule, because you know that this both are located in the superior aspect of the forearm. So both of them, that is the elbow joint and the superior radio-ulnar joint, are articulated or enclosed in a single joint capsule. So this is a brief discussion about the 2 joints in nutshell. Now we look at the elbow joint in particular, the structure and function of the elbow joint. When you look at the structure and function of the elbow joint, you need to look at two aspects. One is the humero-radial aspect and one is the humero-ulnar aspect, right? Let's see. The proximal joint surface. Which is the proximal joint surface in elbow joint? Any idea? Which is the proximal joint surface? It's a distal end of the humerus. Distal end of the humerus. Now, we need to identify few landmarks in distal end of the humerus in order to have a better understanding about the elbow complex. So let us study that with the help of this. If you look at in this slide, I have asked you to identify different landmarks. So this is very important. Be thorough with the landmarks in the elbow complex, right? So the first one is this one that is known as the trochlea, and you can see that highlighted over here. This is the what type of structure, that is the what type of structure. It is a hourglass shaped structure. It is a hourglass shaped structure that is known as the trochlea. And then we have a round structure over here that is known as the capitulum. So the trochlea is seen in the medial side, capitulum is seen in the lateral side. Am I clear about that? So we have two important landmarks to identify here. One is the trochlea over here, one is the capitulum over here. I hope that is clear, right? Then we have a trochlear groove, which is a obliquely oriented, not that easy to distinguish, that divides the trochlea into this one that is a medial aspect of the trochlea and this one that is the lateral aspect of the trochlea. Or the trochlea, which is this hourglass shaped structure, is divided into a medial aspect and a lateral aspect with the help of a trochlear groove. Even if you don't remember that much, the trochlear groove, it's not that a big deal. Then we have a fossa here, a depression here known as the coronoid fossa. Why is it called coronoid fossa? That is because in ulna there is a coronoid process. That coronoid process will come into contact with this at the flexion, maximum flexion. So we call this one as the coronoid fossa. And then above the capitulum we have another fossa. That fossa is known as the radial fossa. Can you tell me why is it called a radial fossa? That's called radial fossa because this head of the radius comes and articulates this with this one. So we call it as the radial fossa. So we have the coronoid fossa, we have the radial fossa. Am I right? I hope that is clear. Then we have a landmark known as capitulotrochlear groove. You can see this one, no? This ridge or this groove which differentiate between capitulum and trochlea is known as the capitulotrochlear groove. That's known as the capitulotrochlear groove. And the posterior aspect, we have another fossa that is known as the olecranon fossa. That you cannot see in this diagram. We'll show in the diagram. Right. So once again, let us just look into the landmarks. Understanding the landmarks is very important to proceed further into exercise therapy, giving mobilizations, etc. So study this one, that is the trochlea over here. This is the capitulum over here. This is the fossa on the above the trochlea, that is the coronoid fossa. Trochlea fossa above the capitulum, that is known as the radial fossa. Remember, capitulum is always in the radius direction. Okay, radius and capitulum is in the lateral direction. Trochlea and ulna is in the medial direction. Now I told you earlier about humero-radial articulation and humero-ulnar. You can see here that the humerus articulates with the radius like this. So this articulation over here, the capitulum and the head of the radius forms the humero-radial articulation, whereas this one over here forms the humero-ulnar articulation. I hope that is clear. Next diagram will again help you. Look at this diagram. I have asked you to identify lateral supracondylar ridge, lateral epicondyle, medial supracondylar ridge, and medial epicondyle. That's not directly coming into the elbow joint, but I still feel that you need to identify and know that thing. Before that, let me show you. This is the olecranon fossa. So this is the olecranon fossa. In this diagram, we can identify three fossas. One is the coronoid fossa, which I have already told you about the trochlea. Then we have a radial fossa above the capitulum. Then here we have the what you call olecranon fossa. So three fossas over this region, right? Yes. And the lateral epicondyle is the place where you have the capitulum. This region after that is known as the lateral epicondyle, and this region over here related to the trochlea is known as the medial epicondyle. So we have the lateral epicondyle and medial epicondyle over here, and something that is lining above, as I show from this cursor, this one is known as the lateral epicondylar ridge. Something above the epicondyle, lateral epicondylar ridge or lateral supracondylar ridge. Supra means above the condyle. If we have a bone, we could clearly distinguish. It would be rough to palpate that region. So that is the lateral supracondylar ridge. You might have heard about lateral supracondylar fracture, etc. Right? No? So that is the lateral supracondylar ridge. This is the medial supracondylar ridge. This is the medial epicondyle. This is the lateral epicondyle. This is the capitulum. This is the trochlea, and this is the olecranon fossa. And this is the cornoid fossa, and this is the radial fossa. So these are the important landmarks that you need to remember with respect to the proximal joint surface. The proximal joint surface is made up of humero-ulnar and humero-radial articulations. In humero-ulnar articulation and humero-radial articulation, the following happens. Okay, in humero-ulnar, it is a trochlea that is present in the humerus, distal end of the humerus that is articulating with the ulna. The trochlea is a hourglass-shaped structure. It is divided into two parts, medial aspect and lateral aspect, by capital trochlear groove. Then it is related to the medial epicondyle and it's seen in the medial side of the forearm. Then we have the capitulum, which is a convex shaped structure present near the lateral epicondyle that articulates with the head of the humerus. And then above the trochlea we have the trochlear fossa, not the trochlear fossa, cornoid fossa. Above the radius we have the, above the capitulum we have the radial fossa, and behind the ulna, behind the humerus we have the olecranon fossa. And you have to identify supracondylar ridge, medial and lateral. Now moving into the distal joint surface. What do you mean by the distal joint surface? That would be related to the radius and the ulna. The distal joint surface will be made up of the radius and ulna. Let us look what are the structures. In ulna, we have the structures like a trochlea. Okay, we have the structures like a trochlear notch, we have the structures like a trochlear ridge, we have the olecranon process, we have the cornoid process, okay, and we have a radial notch. Let us try to identify how we can identify that structures. Again, going into this structure, this is the proximal end of the ulna. You can see that, you know, that ulnar head is directed downwards, not like the radial head, okay, and this is the ulna. The posterior or the superior located process, or the posterior and superior located process over here is known as the olecranon process. This olecranon process is the one that is articulating with the olecranon fossa, and anteriorly located one is known as the cornoid process. So there are two processes, that is the olecranon processes and the cornoid process for the ulna. And this is the trochlear ridge. Can you see from this diagram very clearly the ridge shaped structure that is corresponding to the trochlear groove? We have discussed about the trochlear groove, right? So the corresponding structure to that one is the trochlear ridge. Okay, so in ulna, or in the proximal aspect of the ulna, we have an olecranon process, which is the superiorly located and posterior one. We have an anteriorly located and superiorly located cornoid process. Then we have a trochlear ridge over here, and this caved shaped structure. This would be, if you have an ulna, we can see that it is actually concave shaped structure, that is known as the trochlear notch. This is very corresponding to the what you call the trochlea. You see, this trochlear groove articulates with the ridge, and this medial aspect and lateral aspect goes to the trochlear notch, right? Yes. So when we look at this diagram again, we can see that here we have the radial notch. This direction we have the another structure known as a radial notch. This is also a small concave shaped structure, gap over there, that is known as the radial notch, where head of the radius articulates. So these are the most important landmarks that you have to remember with respect to the ulna. I feel that it might be a bit difficult for you to visualize without the help of a bone, but unfortunately I don't have it right now with me. Kindly forgive that one. Right now, let's move on to the distal joint surface of the radius. There we have the head of the radius, fovea, and capitulotrochlear groove to be identified. Okay, right. So if you look at the radial side, you can see that the radial head is this one. The radial head, okay, the radial head is having an upper or superior concave shaped depression or concave shaped region that is highlighted over here, that is known as the fovea. That is known as the fovea. This is the rim of the radial head, and this is the fovea. So in distal end of the radius, we have the radial head, which is having a superiorly located concave shaped structure known as the fovea, because capitulum is convex shaped. It won't articulate with well with a convex shaped fovea. So the fovea is actually concave shaped. And this rim, right, this rim of the radial head is sitting into the capitulotrochlear groove. We have discussed about a capitulotrochlear groove, no? So this will sit onto the capitulotrochlear groove. And this is how you can see that the head of the radius is sitting in the ulnar notch, the radial notch in the ulna. It is sitting in the radial notch in the ulna. So here the landmarks is the radial head, radial neck, bicipital tuberosity where biceps tendon inserts, and the fovea and the rim. Clear? I hope that is clear with you, right? So these are the important things that you need to write it around with respect to the joint surface. So if they ask you which are the articulation of this one, you have to just write down and pick out the important landmarks. Something that is different in the elbow complex or elbow joint is that you have a lot of landmarks to identify and describe. So you have to be thorough with the anatomy, I believe so, okay? And now the final aspect in today's discussion is how the joint articulation is done or how movements are taking place. Now imagine a situation in which I am flexing my hand like this. Okay, when I am flexing my hand, think about the ulnar side alone. The trochlea is actually sliding in the trochlear notch, and the trochlea is actually sliding. So there is a slide of the trochlea that is happening with the ulnar notch. The trochlea slides with the ulnar notch for the flexion to happen from extension. So when in this region, in this way, it slides away and it slides towards the forearm, the arm. So in flexion, when flexion happens, the trochlea slides on the trochlear notch, or trochlear notch slides on the trochlea. Okay, that is how flexion takes place in the arm. In extension, the trochlea slides away from that. That is in the humero-ulnar side. In radial side also, what happens is that the radial head, right, that slides on the capitulum. That slides on the capitulum. Okay, the radial head slides on the capitulum. Now, imagine this situation. This is an extended position from where I am sliding my hand. The trochlea is sliding, sliding, sliding. Finally, at a point, the flexion will stop. How flexion stops? That is because we told coronoid process, that coronoid process will go and sit inside the coronoid fossa. So when that becomes articulating with each other, the flexion stops. The extension stops when olecranon process, which is seen over here, goes and sits inside the olecranon fossa. Unless and until olecranon fossa sits on the olecranon process, the flexion extension will continue. So the extension will come to a halt when what happens is that the olecranon process goes to the olecranon fossa. Let us see that with the help of diagram. In this diagram, you can see that the diagram B, extension of the right arm, you can see that this is the olecranon process, which is exactly sitting inside the olecranon fossa in the humerus. There is no more movement possible. There is no more movement possible. That bone is articulating or approximating each other. Whereas in flexion, you can see that here we have the coronoid process, which is from this position to flexion increasing. Finally, this both will comes to articulate with each other or approximated each other. At that position, what happens is that there is no further flexion possible in the ulnar side. What about that happens in the radial side? You can see that the same scenario happens in the radial side. From this extended position, when flexion increases, this is the capitulum, the radial head and the fovea slides on the capitulum. And when radial head finally reaches this radial fossa, what happens is that flexion stops. Flexion stops when the radial head reaches the radial fossa. I hope that is clear with you. And you can see from this diagram, there is a peculiarity, like in full extension, there is no contact between radius and the humeral articulation of the capitulum. You can see that there is actually a joint gap. That is because there is actually a joint gap because of the less contact or no contact with the capitulum with the trochlea. Capitulum with the radial head. So here at the full extension, you can see that there is no contact, and you can see that if you are placing the hand in full extension, of course the mobilization is very easy because there is no articulation, so you can easily move your humerus here and there. Okay, just you can try that one. It's interesting to know. And finally, the last point over here, I told you earlier about the trochlear notch, which is actually a concave cavity over here, and if you see an ulna in real, you can see that it's having a very large cavity. But the trochlea of the humerus will not articulate in depth into the ulna. So in this normal position, when I am placing my hand like this, inside that, if this is the trochlear notch, my trochlea might sit only in this much region. Only there might be a slight articulation. So trochlea will not go in depth into the trochlear notch because there is no need of that. But when I am placing my hand in this board like this, in the wall like this, I don't know if you can see that, what happens is here, there is a close contact, or there is a close chain that is happening. At this time, my arm is loaded. Now my trochlea will go inside into the trochlear notch. But in a normal resting position, in this movement, the articulation between the trochlea and the trochlear notch is very less. Articulation between the trochlea and trochlear notch is less. You can see that here, this green line shows the joint gap that is happening. Now the person, when he holds on this board over here, it's not that visible. You can see that the trochlea will go inside, trochlear notch will go more inside to the trochlea. There is more joint approximation. Okay, and also remember the head of the radius is slightly larger compared to the capital, so that joint is also incongruent. So these are the important things that I need you to remember with respect to the elbow complex as the brief introduction. Hope that was clear with you, and I know that there are some drawbacks of not having the board right now, but if you are able to adjust, I will be most happy to know. And if you like the video, don't forget to click like button and kindly share with your friends.